All right, hey folks, how are you? So that is a hard opening to follow. My name is Bob Allen, and what we're going to do is talk about some of the work that we're doing with analytics in general, but just Azure in particular at FEMA. Hey, what's up, Tyler? And okay, so the federal government is a different beast, and trying to get them into new technologies is challenging. One of the things that we're finding is perversely cost. So budget constraints actually help us with innovation. We look at the mission that the agencies have. The missions keep getting bigger and more complicated, and the budget keeps getting reduced. So what we found is that kind of standard CIO reticence to doing something different, moving to some different technologies, using cost as a driver, we've actually been making an enormous amount of progress in the last 5 years. So I think we were the first federal FedRAMP system, certainly the emergency response system in Azure. We got our first Azure system up, that's 5 years ago following Fukushima disaster. We are a software company in Tyson's Corner. We've been in business for 15 years, and we have a specialty in emergency response and rad nuke we call methyl ethyl death. So anything bad that happens, that's what we actually do. So what I want to talk to you about today is two mission areas that we're working in. My guys who don't allow me to code anymore, so I can't go into the detail that Chandra went into, are actually working all night on hurricane response. So we'll talk a little bit about what that mission is, but I can go ways into the technology on it. So what we're going to do is look at a long-term project that we're working on right now, and then we're going to wrap that up with something that we did immediately during Harvey and Irma. So what we've proposed in the client is, if we know that an agency has a mission, we know that mission is continually getting constrained by budget, the mission gets continually more complicated, how do you fix that problem? So we've started talking to them about applying value chain analysis. Now, something very interesting in what Chandra said, most of what I'm going to talk to you about is not exactly cutting edge technology. I was writing GAs in 1991. So, and learning about neural networks. This technology has been around. This way of looking at problems has existed for a long time. The approach, what's different about it now is the consolidation and how you can actually bring the integrated technology to bear on them. So for anybody who's like, an MBA or a business type, value chain analysis has been around since 1985. You've got all of our inputs into our process. We've got our outputs of the process. We know how much money we make. You add them all up, you drop into a model, and you say, and you figure out if you're GE, which factory you want to close, right? So we've been doing this for a long time. When you look at it from a private sector, or in a public sector, how do we build that same type of model where the input isn't a dollar? So we look at FEMA's mission, and we've got 30,000 responders. We have, those folks fall into 20 different hiring mechanisms. So how they get into the agency. We have regular FEMA employees. We have these folks called cores that are on these 2-year contracts and they can be let go. We have 7,000 people in a reservist cadre. So these might be retired firefighters, retired cops, state and local folks who are just waiting around for the call to go out. We have got a very wide distribution in our age. We've got a huge distribution in not just in pay, but how these people get paid. FEMA runs its own little university system. So they've got campuses up in Emmitsburg, Maryland, Anniston, Alabama, federal law enforcement training centers, all the regional offices. You put it together and it's like its own college. We're executing 40,000 individual training sessions per year. Each one of those training sessions is going to have hundreds of different instructors, different locations where they're offered, how that training actually gets delivered, and I say tens of millions of dollars a year because that's the direct training budget for disaster responders. When you actually put it together with the drills and exercises and the entire world of professional development, this is $120 million a year. On the back end, if we're going to construct a value chain, we've got to figure out how do you measure a return on investment? How do you actually monetize that? So we're not selling a widget. We don't have dollars going into the system, but we're collecting an enormous amount of data. So we design, build, run their deployment system, their qualifications management system, substantial parts of their training management systems, planning, analysis, all these different pieces. We also run a very large portion of their grants administration. These are all running in Azure, and what we've done is, on the slide, construct our own data lake. So we can start looking at all these silos of data that historically had been in all these separate parts of the agency, very often on spreadsheets and running in SharePoint, and we actually have them. So in terms of the volume, because we joke internally, it's not big data if it fits on a thumb drive. So we needed to get to a critical mass of data that we can start doing something fun with. So when we look at it, about 100 declared disasters a year. You hear about Harvey, and you hear about Irma, and you hear about Maria. There are 3 county floods and 6 county floods and straight line winds and winter storms all over the US every year, but if you live on the coast, you typically don't hear about them. So about 100 declared disasters. For our responders, we execute somewhere in the neighborhood. This year is probably going to be well over 100,000, but 100,000 individual deployments. So a deployment is a guy gets requested, or a resource gets requested for a mission. That guy has to be qualified to do that mission. He goes to the field, he does his job, 30, 60, 90 days, he goes home. Nobody has ever been able to think about how we connect these two ends. So what we've been able to look at is we don't just have 100 plus disasters a year, 100,000 deployments. We built a personal evaluation system for them so that they can actually record how people did in the field at the end of their job. So for each of these 100,000 deployments, I'm going to get 3 to 5 individual reviews coming out of these guys. That should give me about 500,000 data points a year. And if you start thinking about your chain, what's the work they're doing? If you're in the public, you think that FEMA is setting up tents and handing out water. And they do that. That's an important part of their mission. What FEMA mostly does is write checks. So up on the screen, I've got the public assistance program. Public assistance program that we run a good portion of and own a bunch of the data. That's going to write $5 to $10 billion a year in checks all over the US. Individual assistance program, much smaller checks, and they only add up to maybe 1 to 2 billion total, only in DC, right? But maybe 1 to 2 billion total. But that's going to be to hundreds of thousands or millions of individual families recovering their businesses, recovering their homes. What I hope you can start picturing is that data lake is getting very full. Now we can start applying metrics to these things. So when we look at the inputs into our system, that individual responder, that's FEMA's resource, that's their product. That's the first thing you're looking at a value chain analysis. What's what they're selling? What do they put in the field? That's our responder. So we actually have them deployed and they're doing their job. How do they get there? What are the inputs to our value chain? How do they get trained? How do they get qualified? Now when I get qualified, I get this thing called a task book. That task book gets issued to me. It might take me 2, 3, 4 years to get qualified. That task book might have 50, 100, 200 tasks. I go to the field, somebody observes me doing my work, they give me an evaluation, I gradually start getting my task book checked off. At the end of this process, I may have worked with 5, 10, 15 different mentors getting that task book created. I may have had to attend 5 or 10 different training classes. Now that training class that I offered, that might get offered at 20 different locations across the agency. It may get delivered in either I'm attending an individual course, I'm attending a remote course, I might get sent down to Anniston, Alabama for a month, and I'm taking 4 or 5 courses in a row. So the actual mechanism of how I get that course delivered to me, extremely variable. How often I've been in the field? Have I deployed in the last 5 years? Am I a 62-year-old reservist in Missouri and I haven't rolled out the door? And now I go out there? How long has it been since I've been trained? And the actual specifics of the qualification process. How did I get qualified to be able to do that job? So those are our inputs. When we actually go out into the field, what is the job that I did and how do we manage it? How do we measure it? So we already talked about a personnel eval. So when I complete my job, anybody that I reported to for at least 15 days, they get a bite at the apple to do an evaluation for me. How has this been getting done for the last 30 years? On paper. Not collected, not captured, not managed, certainly not structured. Survivors. So the folks who have survived the disaster, they get assistance, they fill out surveys. That information actually all gets captured. Administrative costs. I am legally prohibited from telling you exactly how much administrative cost there is on that grant, but it is substantial. Remember, we've got 100 different disasters. So this mix of people, that's why we got all the lines here, how they got there, how they did their work. We had, at the peak, we had 6,000 responders working at Harvey. We've now shifted 2,500 of them are at Irma in Florida. I talked to my guys tonight, so we've got a whole bunch of our folks in Puerto Rico. I don't know how many people we can physically get there, but then those folks shift. Just try to picture with that many individual deployments, that many training mechanisms, this many disasters, this many applicants, how many different paths that you're looking at. The way the agency has done this is they've got an entire group of analysts, and they get spreadsheets, and they do a lot of averages, and they guess. And they're great. They're fantastic. I've been doing this work for a long time. I work for a lot of different agencies. They are by far my favorite. They're extremely dedicated. They get very jazzed during this season, but it's a bear of a job. And this grant delivery, that's the big thing. What are the administrative costs of getting that $1 of aid out the door from the time that application was made? How quickly do we do it? So I was talking to some gentlemen earlier about Geico. FEMA is a giant insurance company. So they do emergency response, they're delivering aid, they're putting people in tents, they're setting up communications, but they're an insurance company. So what are we doing for them? A number of these components have been running for about 2 or 3 years. So I'm now at the point that I have, in some of my data sets, 10 million data points. We've gotten to that point of that critical mass that we need to actually have enough information to start doing real analysis on. So what do we got? How many students are in the class? There's an entire department there called Curriculum Design and Delivery that runs this little university department. How do they make sure that they have a prepared workforce? Emergency response is a weird business because you don't know when it's going to happen. We've been in extremely low disaster activity for 10 years. 10 years. So certainly since Katrina and like the 3 storms during Katrina. So you've got a workforce that you need to have ready and have in your back pocket for a disaster to occur, but you don't know when the disaster is going to occur. You don't know how often it's going to happen, how big it's going to be. God forbid if 3 hurricanes hit back to back in Region 4. So how do you maintain preparedness for that workforce so when the balloon goes up, they can actually go out and do their job? One of the things that I bring up a lot is the difference between DoD and civilian. DoD can say that we want to run a 2-theater war, so they can just make 2 armies. And they can say we are fully prepared to fight in a Pacific and a Atlantic theater at any given time, because they're DoD. Civilian agencies can't do that. They don't have the money and they don't have the people. So we can now look at the right side of our chain. We can look at our evaluations. We can look at our surveys. We can look at a whole bunch of statistics on our grant delivery. We can look at, most importantly, our administrative costs. So how efficiently was FEMA able to do this job? And then I can look at how we got those people out the door. Because a lot of times we refer to these folks as program delivery managers. So how do they deliver the benefits of that program? And we'll talk about this a little bit in the next slide. But what we're doing now is we've got a machine learning instance spun up. We are using some of the built-in R models, and we are just running a massive multivariate linear regression and clustering. I'll get to this in the very last slide, but I even feel this way when I have to present it or talk to customers about it. There's a little bit of a so what. So I'm like, you know, my takeaway is like, well, we're going to do a linear regression. You're like, oh, okay, it's fine. We've only been doing that forever. But there's a reason that's interesting. Because what we're going to do here is tell them when they're designing their courses for the next 5 years, and they're laying out their class structure, and they publish their catalogs, and they know how many students we're going to have in each class, who our best instructors are. Do we send students for one-off trainings? Do we send them to consolidated trainings? Nobody knows the answer to those questions. They keep tinkering with them, but no one knows. And they spend a lot of money and a lot of time thinking about this stuff, and they've never actually had the data or the tools to actually run an R model on it and have it kick out and say, here's your actual cluster. Here's your biggest bang for your buck in training your workforce and preparing them to actually do their job. So that's a long-term project. We've kicked that off this fall. We are going to be running all kinds of models on it, and what's nice with some of the stream analytics stuff, the data set is continuously updated. So since we run a whole bunch of these pieces, we have 90,000 hours of usage a month. The data is updated literally second by second. So we're able to train our model. We know how folks performed in the field, and we can keep refining. So this is going to be going on, I'll say it's going on for the next 2 years, but this is just going to be going on forever at this point. This is a little neater. In the middle of Harvey, Harvey was really bad. So all the attention is on Irma and Maria. Harvey is bigger than Katrina. Much lower loss of life, thank God. But in terms of actual impact, number of homes, dollar value, Harvey's probably going to be the worst disaster in the history of the United States. And just, it sat off the coast and it just rained. So everybody's been sitting around waiting for a disaster. And a lot of these folks that deploy, they get paid more when they deploy. So they all get very excited, and folks in the agency, they get fired up because they've had nothing to do. Nobody's died, it's been boring. And all of a sudden the balloon goes up, got a big hurricane. A lot of these folks have never actually gone to the field for a level 1 incident before. So everybody and their brother wants to go down to Texas. That's Region 6. Region 6 maybe oversubscribes because they know how big the impact is. So we end up with 5,000 to 6,000 people there that quick. And that's fine because they're going to do their job. It's a big mission. The standard typical size of the workforce in FEMA is about 14,000 deployable responders. Then you've got another 6,000 to 7,000 on top of that in reservists, people that aren't really going to go out the door. If you've noticed, I said that our workforce right now is 30,000. Here's why that is. We start looking at our models, and we see that we've got this many people deployed, and we've got this whole thing called force structure. We can model how many resources that we want at different disasters, and we start seeing a storm track. And it's out to the ocean, it's not out to the ocean, and holy shit, it's at Miami. And then everyone freaks out, and then it shifts, and now it's coming straight at Tampa. Well, we already have all these people here. The question now becomes, what's left in the tank? How many more people do we have? Now, we can bring up the system and we can see what the actual availability is, but we know that these people aren't military, so they don't get a deployment order and they just have to go wherever they're told. They have an option, especially our reservist workforce. They don't have to accept a deployment. And now you get into very serious decisions. Is FEMA going to hire? We've hired, gosh, 7,000 people in the last couple of weeks. This is called local hires. You get people from local community. There's a program that's been in place with DHS for the last, I think, 7 years that had never been activated called Surge Capacity Force, which means that there's about 7,000 employees in other federal agencies that get operationally shifted and they get owned by FEMA. Anybody work with federal clients? How excited do you think they are to actually get that switch turned on and they lose all their people who are doing their day job, and now they've never deployed to a disaster and they're getting sent to Texas? Do we start stripping people from Region 5 and moving them over? These are very politically sensitive decisions. These are, you can have a bogey of tens of millions or hundreds of millions of dollars. Once you hire somebody, you hired them now. If you have caused bad blood with another federal agency, that's now on your budget because you've pulled all those people over. And what do? So what we did is took basically the last 30 years, but especially the last 2 years of actual real deployment data. In real time, we worked with our counterparts at FEMA. We spun up an instance. We're able to take the actual history of what we call our declination. So when we actually request somebody to go to the field, how likely is it that they're able to accept that request? This information is constantly updated because it's going to depend some of the things that we are dropping into our model. How far are they from the disaster? How old are they? How many days have they deployed in the last 6 months, 1 year, 2 years, 3 years? Is the position that we want them to deploy them in, is that their primary or one of their subordinate positions? Have they deployed to that region before? Do they have any knowledge? Have they deployed to that state before? All of these things start adding up. Because what we want to do is get away from a crude number of how many people that we actually have that we're able to deploy to in real time. So the new administrator who, this is his first job, right? They need to know these decisions. They need to know, are we hiring 500 people? Are we hiring 1,000 people? Are we hiring 5,000 people? How many people are we going to move from Region 6 and send them over to Region 4? The models got built in about a day and a half. They're perpetually updated, and this is what informed the entire response, the ongoing response to the rest of the disaster. So it was very exciting, and it was a pleasure that it actually worked, because it would have been bad if it didn't. And the important thing, and this goes along with what Chandra said, and this is the most important part. So everything I just described, you could have done 20 years ago. You could have done it slowly, but you could have pulled in data, and you could have built models on it, and you could have run your regression, and you could have come out with a work product. So the end state that we were able to get to in about 36 hours, I could have done in 92 or 94, right? It's just math. There's no magic to it. It's nothing changed. The difference is the tools and the integration. So we already have all of our data in Azure. If we want to do something during this disaster, for folks that are like Azure Pass people, we normally run on P4 for steady state, occasionally on a P6. We've got full geo-replication, everything scaled up and out. We're at a P11, occasionally going up and down to a P15. All of our web apps popped out. Customers never saw it. I used to have to configure Wolfpack, like it was like Wolfpack for SQL Server. You needed a PhD just to cluster a SQL server, and now one of my guys can go in and check a box. And we're running on 3 data centers, and then we see we got a performance problem. We say, well, let's take a read-only model and move a read-only model over here for all the new BI they want to hook to it, and we can do those things in 10 minutes, and it just works. So companies like us, that we are purely operational and mission people, we are app dev guys. That's all we do. We are not infrastructure, and we don't have to be. We don't have to care about it. We stay very much in our lane. We focus on what we have expertise in, and we do not have to be hardware guys, and we do not have to be networking guys, because that's not what we do. So it's a joke here. We've got a couple of young fellas that we work with, and this is where you're not a data analyst or a big data analyst if it fits on a thumb drive. They're the origin of that. But anybody who's less than 25 now is a big data analyst. I remember a couple of years ago, everybody that you met was a social media engineer, and I think all those social media engineers are now big data analysts. But that's what everybody is in the agencies now. Instead of them writing their R models and they're sitting on their little government-issued laptop that has no juice, and they pull the data down, and then they're going to build their model on it. In our world, by the time they've built the model, it doesn't matter. Like if they generate something 4 hours after they pulled the data, much less 48 and 72 hours after they pull the data, the model has no meaning. So instead of them pulling things locally and they're running their statistical packages, what do? We have a place where they can run it. And if we want to add more instances, if we want to add more juice, we check a box, and we have more processors. The other thing that we're finding, I had a guy at Microsoft forever ago tell me about the Airman Snuffy problem. It was, for those of you who've been around long enough, there was the RAD JAD days where all of a sudden everybody had Visual Basic, and in an organization or an agency, everybody had applications, right? So everybody could build little applications, and you ended up finding that there was some mission-critical Air Force application that ran under Airman Snuffy's desk on his P2 tower. So we went to that world, and then we've gone to this consolidation data center world, and now with a lot of these tools, we're spreading out again. So we've got all these guys doing analytics, and they've got great tools, but they're all back to doing them on their laptops. So you have repositories. They're not building everything locally. If we're doing this work for one disaster, it goes someplace. You can refine it. Other people can work on it. You have an entire environment to work in. So we have the data. We have the processing power to get you off your laptop. We have all the built-in models. So not only are we building our own R models, we have everything that's already built into Azure, that when you've got somebody who's new to this, they can say, oh, well, I'm going to open up analytics, and I'm going to look at one of my R models, and oh, what's this clustering model? And they have a place to start from. That whole getting over the hump of getting into this world, much, much lower. And visualization, Power BI. We're figuring out how to integrate the dashboards. So now we actually have a delivery model for this for senior decision makers that looks super snazzy. And the thing that I'm going to close with, I used to be more technical than I am. It just breaks my heart. But I have been a business owner for 15 years. And we are a small company, and we have to compete with very, very, very big companies who hate us. Cost. When you can spin up this analysis, and it's a couple $100 a month. Some of these entire infrastructures, mission critical, run substantial portions of an agency. We do a lot of nuclear weapon stuff. We do chemical, biological weapon stuff. We do all kinds of cool things. These environments that we're on might cost 20, 50, 100 grand a year. Maybe one of the really big ones might cost 200 grand a year for the biggest hitter. You can't compare that if you've been doing this work for a long time, and you would look at a traditional hosting, traditional infrastructure, that when that CIO goes to your mission owner and says that's going to be a $4 or $5 million bogey on top of your program. So the cost of being able to do this, the cost of being able to lowering the bar and having the prepackaged models, having a consolidated environment, and having it be cheap. Because I think what everyone in this room should be doing and what everyone in our industry should be doing is we want to get We want to get more kids in the pool. We want to get more people doing this work. We collect the data, we own the data. How do we make it useful? How do we actually drive decisions? And in our case, that save lives and recover, help our survivors and our recovering communities get back on their feet. At which point the American flag drops. But thanks very much, and I'd be happy to answer any questions. Thank you.